Hi, and welcome to the first day of the fourth quarter. The Unit 15 packet has been posted on Edmodo. Since you don't have a physical packet, you have two options. You can either print the packet. If you're going to do that, I recommend you using double-sided printing, so you only have to use 10 sheets of paper. But if you do not have a printer or you can't print, that's fine. Take out some loose leaf paper or graph paper, and you can write the notes and examples on that. Just be sure to label the graph paper or loose leaf paper with the page numbers and question numbers as you go. First, we're going to be taking a few notes on the front cover. And again, it is fine if you do not print the packet, just take notes on a separate piece of paper. On the front cover, the first thing we need to go over is where all the calculator buttons are. Now, f of x equals a is a constant, which we have done before. This would be the equation y equals a number, since it is a horizontal line. Next, we have a line, which is a linear function, which we've already talked about before. Next, we have what's called an absolute value graph. An absolute value graph will always be in the shape of a V. In order to get the absolute value on your calculator, make sure that you write down it's alpha, window, ABS, or you can hit math, number, ABS to get the absolute value button key. Next, we have what's called a step function or greatest integer function, which we'll be talking about later in the year. A quadratic, we've already done before. As you know, it's going to be in a U shape. Next would be a cubic. A cubic means that there's going to be an exponent of 3. To get an exponent of 3, you're going to be using the caret button with the exponent of 3. The square root, we've done this before. You would have to hit second x squared in order to get the square root button. And a new one would be the cube root. And in order to get the cube root button, you want to hit math, and then the cube root is a radical sign with a 3 here, so you would hit math number 4. Let's go on to the next page. On the next page, you're given the graph, the table, a function type, the parent function, and then some key features or observations. So on this first page, we've already gone over the graphs of lines before, but just a few reminders. One, the parent function of a line is y equals x, or f of x equals x. What you do need to know about the table is that it's always going to be increasing at a constant rate. So if you look at your x values, it increases by 1, increases by 1, increases by 1. For your y's, in this case, they're also all increasing by 1. Since there is a constant rate, this would be considered linear. You may need to pause the video at certain points to make sure that you get down all the notes. So again, be sure to write down that your table would be increasing or decreasing at a constant rate. You also need to know that the first differences are the same. That means when you subtract the y values, you must get the same number. If you don't get the same number, it will not be linear. The next graph is an absolute value. An absolute value function is always going to be a V shape. The table for the absolute value will be similar to the parabola, where in the center of the table, you will always find your vertex or the turning point. So when you are graphing an absolute value, you'll be lining up both the top and the bottom, just like you would before when we were graphing parabolas. The next graph is going to be a quadratic, which we have already graphed before. Remember, a quadratic will always be a U shape when you're graphing it. Now, as far as looking at the table, you do have to be able to tell whether or not it's a quadratic by looking at the table. When you subtract the y values on a table and you look at your first differences, if those are the same, it would be linear. But in this case, we have 5, 3, and 1. Then what you're going to be doing is called the second differences, meaning subtract the y's again. And in this case, we get the same number of 2, which is how we know that this is going to be a quadratic. So again, if the second differences are the same, you know that it's a quadratic. That means to subtract your y values twice, and if you get the same number, that tells you that the table is representing a quadratic. The next graph is called an exponential. An exponential function we're going to be talking about a lot in this packet and also in our next unit. Now, as far as an exponential goes, when you're looking at the table, you need to see whether or not it has a common ratio. A common ratio means if you're multiplying by the same number to get from one number to the next. To go from 4 to 8, you multiply by 2. To go from 2 to 4, you're multiplying by 2. 1 to 2, you're multiplying by 2. If you're multiplying by the same number, that means that you have a common ratio and the table represents an exponential function. The parent function of an exponential would be y equals ab to the x, or sometimes you may see it written as y equals b to the x. So again, if you're multiplying by the same number, and in this case you were multiplying everything by 2 in the y's, that implies that it is a common ratio, therefore it's going to be an exponential. The next is the graph of a square root, which we have graphed before. In order to graph a square root, always take and look for error on the table. That's how you know where to be starting your table. The parent function of a square root would be y equals the square root of x. The next one, which is going to be a new graph, is called a cubic function. The parent function of a cubic is y equals x to the third. Underneath it, we have the cube root function, and the parent function is y equals the cube root of x. If you look at the tables, you're going to notice that you're still going to be having the same number with opposite signs when you're setting up your table. And for the parent function, it will always be going through the center at 0, 0. As your graph shifts, obviously this is going to change. And on the bottom, we have what's called a piecewise function, where it will be pieces of graphs connected to form one graph. Now be sure to go back at some point and read the right-hand column on function clues, key features, and observations. On the next page, on the top, they want you to take and identify the graphs as linear, absolute value, quadratic, or square root. Pause the video now and fill in the names of each function. The first graph would be linear. The second graph is a V-shape, which means it is an absolute value. The third graph is a U-shape, making it a quadratic. And the last one would be the square root graph. The next section is asking you to identify the function as linear, absolute value, quadratic, or square root by looking at the table of values. Try those now. Pause the video first. On the tables, you're going to see the first table, all of the y's are increasing by 1, meaning there is a constant rate, which makes it linear. Or you can say first differences are the same, meaning you subtract the y's once and you get the same number. The second table is an absolute value, because when you take the absolute value of -2, you get 2. The absolute value of -1 is 1. The absolute value of 0 is 0, making the second table absolute value. The next table would be a quadratic, because the second differences are the same. That means you subtract the y's once, and you get 5, 3, and 1. You subtract the y's again, and you get 2, making the second differences the same. And on the last table, as soon as you see the word error, you should realize that it's going to be the graph of a square root. On the bottom, pause the video and fill in the correct function or equation with the appropriate graph. I'm assuming most of you used your calculator to type in each equation and to match it up with the graph, which is a completely fine way to do this. Another way to do this is to realize what the shape is looking like. The first one is the graph of a cube root, and you're always comparing it to the parent function, which goes through at 0, 0. So then you would realize that this went up 2, and if it got shifted up 2, you would have had to put a +2 on the end. The next would be a quadratic, so you would have to pick one of the equations with an x squared in it, and again, if comparing it to 0, 0, you would see that this went down 1 and to the right 3, making it x minus 3 squared minus 1. The next would be the graph of a square root. Since this is starting at 0, 0, you're not going to have anything connected inside of the radical or after it. The 3 in the front extends it or shrinks or expands the graph. Next, we would have a parabola again. Therefore, you would have to have an x squared. The next one would have to be the graph of a square root. And the last one would have to be the cube root. Going on to the next page, this is just a review of all of your transformation rules. I wrote out the word hyobos for you with the notes written in it. Horizontal, inside, in the opposite direction. Vertical is going to be the outside number in the same direction, with a few of the notes underneath showing you if it's outside, it's going upward. If it's inside, it goes left or right in the opposite direction. So be sure to review those and look those over if you forgot those rules. On this page, the first thing I need for you to do is to take and cross off these 3 boxes. Now, the parent function of each one for a line would be f of x equals x. Next, they want you to use g of x. G of x equals the absolute value of x. H of x equals x squared. And P of x equals the square root of x. Using your transformation rules, take and write the new equations for the shifts that are given. Always use your calculator to check your final answers. Pause the video and do that now. Remember, when you're writing a new equation, if there is a shift going up 4, you should have a +4 on the outside of your equation. When you're going to the left or to the right, that's telling you that it should be on the inside, going in the opposite direction. Pause the video now and double check all of your answers. Your homework for tonight is 20 minutes of IXL. The sections are already highlighted for you. You should work on each section of IXL until you get 85% mastery. Once you get 85, you can move on to the next section. You will work on IXL until you get at least an 85 on each section, or 20 minutes total, whichever comes first. So you can stop after 20 minutes even if you do not get to complete all of the sections. Make sure that your entire packet or loose leaf paper has everything complete up to page 6 where we filled in the table. Have a marvelous Monday. I will talk to you tomorrow. Bye.